Yani, I would like to see some of you in the location, the place, and the post that Ahmed Abdulkader is currently holding in Facebook and other places. We already seen that when we dreamed about it at another place in Egypt, and we've seen some of our students now in Google, in Facebook, in different places. So we are waiting to witness the day when we see you there, some of you at least. And now, can we welcome Ahmed Abdulkader to speak to you? The second thing I said, the second thing that I said when you were not listening or you were not hearing me because of the mic problem is that Ahmed wanted to be here face to face with you. He is actually in Egypt, but he was tested COVID positive. So unfortunately, he is giving it remotely from home. So please welcome him double because he is giving you this lecture or talk even while he is tested positive. So allow me to welcome him.
It's our pleasure today to have as our guest speaker, Dr. Ahmed Abdulkader, as our guest speaker at Egypt University of Informatics. Dr. Ahmed Abdulkader is a distinguished scientist at Facebook, Applied Artificial Intelligence Research. He's an industry expert with over than 50 publications and patents in machine learning and artificial intelligence. He invented Deep Text, a deep learning text understanding platform that is widely used at Facebook. Prior to being at Facebook, Dr. Ahmed was the co-founder and CTO of Voicea.ai that was acquired by Cisco in 2019. Dr. Ahmed also worked at Google, where he built the optical character recognition and verification of Google's book search. He is also one of the pioneers of Street View at Google, a computer vision platform for privacy protection and scene understanding. At Microsoft, Dr. Ahmed was one of the pioneers of handwriting recognition technology. He was one of the earliest contributors to Arabic OCR and handwriting recognition. He was the co-inventor of the first Arabic OCR engine in 1994. Actually, the biography of Dr. Ahmed is too rich, so I am trying to summarize it so that we have enough time for the talk. We are so glad to have Dr. Ahmed with us today. The talk title is about technology and automation of labor. Thanks, Dr. Ahmed, for sharing the talk with us, inshallah. We are looking forward to the
Thank you very much. And as it was said, I would have loved to be with you guys. It would have been an honor to see the university, see you and hear from you. So my apologies for that. I had the unfortunate luck to actually be diagnosed with COVID. I tested positive a couple of days ago. I'm feeling slightly better, but if I say something, if I hallucinate today, don't mind me. Challenge everything I say. No, seriously, it's a great pleasure. Not sure what the protocol is going to be. I mean, this talk is for you. If you prefer to ask questions while I'm talking, I'm totally fine. If you want to wait until the end and dedicate a few minutes or 10 minutes for questions, that would be fine with me too. So whatever the protocol is. Can you hear me fine, by the way?
Yes, we can hear you, Dr. Ahmed, and the protocol is really yours, whatever you like, but maybe at the end would be easier to handle, I think, if you like, unless it's
makes a lot of sense. Yeah, it makes a lot of sense. All right, let's start. So this is also, I've been building AI, machine learning for a fairly long time. Even before I left Egypt, my graduation project was using neural nets, and this was kind of rare in the 90s. So I've been hooked since then. And we were activists. We were trying to advocate AI that actually works, that it's useful. Now we're living in a different world when everyone knows what the value of AI is. And it's just a matter of putting it to the right use. Now, as useful as it is, it turns out it has some adversarial impact. And it is something I'm very, very interested in. I'm interested in social justice and equality. So this topic is very important for me. And I thought it would be a good topic to talk to you about, especially it actually touches us as, you know, as a society in Egypt as well. It's a challenge, but as I'm going to say in the end, it also is an opportunity for us. So I'm going to talk today about the impact of AI in the labor market. All right, so we have seen very profound changes in the workplace in the past years, and from people can now communicate in a much more efficient way. They can access each other using text, using Slack, using email, and much more efficient communication means much more than before. COVID actually, one of its interesting advantages, if there is any, is that it actually allowed us to work from home. We were able to, using the communication technologies and the video conference technology that we have, we're able to work from home. And many businesses reported that they didn't see any downside to doing that. Some did, of course. Some actually reported positive improvements, working from home. People like me, whose work is to do math and AIs, we really didn't need to see each other face to face. Of course, it's useful. So I personally have been much more efficient actually working from home. This was unheard of before. And, over time, we're seeing a significant increase in productivity due to technology in the workplace. Pay attention to this guy. So this is a guy called Mark Andreessen. This is, most of you are young enough, you would not know Netscape. Netscape is the first browser. And this first browser, second browser that I used. It was very prevalent until Microsoft killed it using Internet Explorer. He is a major VC in Silicon Valley and a visionary. And the things he says are profound, and his predictions are, interesting. People do pay attention to what he's saying. So he said in 2011, he wrote an article in the Washington Post saying, software is eating the world. Okay. And then he went on to explain. And let's take a look at what he said and what it means and whether it's true or not. All right, so 20 years after the 2000s, many of us witnessed the dot-com bubble. It's burst. There are, a dozen or so companies in Silicon Valley, like Facebook and Uber, and they come with a lot of, controversy. All aware of. I don't need to tell you about the controversy that comes with Facebook. Every day it's in the news. Uber also, their practices with drivers, their practices with their clients. There's a lot of controversy around them. However, they are actually people cannot live without them. If you recall, when Facebook went down for a few hours, I'm not sure how people felt. I felt isolated. And I knew people who were really annoyed. I know many people whose work is dependent on Facebook. All right. So put that aside. Something interesting about tech companies in the stock market, there's this thing called PE ratio, which is price to earnings ratio. It essentially is the ratio between how much the stock market is pricing a particular company compared to its earnings. And ideally it's one, but if investors are really optimistic about a particular company, the PE ratio is very high. Otherwise, it's low. If like stable companies tend to have very low PE ratio, and for some reason, the stock market doesn't really give high-tech companies a big PE ratio. It's not friendly to them because it understands that there's some volatility to it. The company could be in the lead at some point in time and could easily be overtaken by another company in the tech, and this happened a lot. Facebook's predecessor, which was called MySpace, many of you may have heard about it. It ceased to exist in a few months after Facebook came over, and so on. Many of these companies are kind of replaceable. Theoretically, there's no reason that a new search engine, wouldn't emerge and people would leave Google and use it. Almost costs nothing. Of course, it's very unlikely to happen. Search is not an easy task, but theoretically, nothing prevents another company from taking on this. So there's a lot of dynamics that's happening there, and as a result, investors are always skeptical about high-tech companies to the extent that they don't end up having a big PE ratio, including Apple. Okay, let's take a look at this interesting story. In 2001, there was a big company called Borders. They were a book reseller, a bookseller, and I think they were a publisher too. They were very prominent in the US, them and Barnes and Noble. And, ebooks was starting to emerge as an interesting, thing, but they were not very much interested in it. So they decided to give their online business to Amazon, a small company that was emerging back then. And because they didn't think that the sales would be that great. And of course, the rest is history. Borders don't exist today. And I think, almost every one of us knows what Amazon means. So that's quite a transformation in a reasonably short period of time. So it's one software company that basically became in the publishing and book sales, so much so that they eliminated actually lots of the prominent book publishers and resellers. So we're really living, that's my thesis, living another industrial revolution. And it involves a major technological and economic shift that we're witnessing right now. And it started happening, I would say 10 years ago, but now we're in the midst of it. And I don't know whether it's the peak or not, but we're definitely at a fairly advanced stage. And essentially, software companies are poised to take very large, swaths of the economy, and many businesses will cease to exist. They will just not exist anymore. And as you'll see in the examples I'm going to give, it's not limited to, for example, blue-collar workers or repetitive jobs. It's, thanks to the technology that's being invented, that's not the case. And I'll take you through this. All right, so let's talk about this thing called SaaS, software as a service. It used to be that people build software and sell it in the forms of, maybe many of you don't know that, or haven't seen that. Software used to ship on floppy disks, or later on CDs and DVDs, and it would be distributed accordingly. I bought several versions of Windows on CDs and DVDs until a major transformation happened, and people started thanks to the internet, putting their software in the cloud, and software became a service, an online service that you get. It has huge advantages. You can do upgrades and fixes on the spot. Windows used to ship every 5 years. That's no longer the case. Updates are happening almost daily, if not many times during the day. And it became much more lucrative, actually, also for software sellers, software developers. And there's much more control over piracy and so on. And so it was good for everyone, good for the consumer, good for the software developers as well. And SaaS is one of the main reasons that we're living this revolution. I don't think it would have happened, using SaaS, not using SaaS. So to be clear, the Facebook is SaaS, Google is SaaS. The latest versions of Microsoft Windows, you can actually install from the cloud. You don't need to get CDs or DVDs, as I said. Office is Office.net right now, which you can run in the cloud. So I'm hard pressed to find any interesting software that is not in the cloud anymore. All right, so 7 decades after the computer revolution, 5 decades after the invention of the microprocessor, and 3 decades into the rise of the internet. So all the technology required to transform industries through software finally works, and it will be widely delivered at a global scale. This is essentially what's happening. It took a long time, but we're at this point in time right now, and SaaS makes it very, very easy to launch any new global software that covers many industries in literally a matter of minutes. In 2000, the cost of a customer running some internet app was $150,000 a month, roughly. Now the cost on AWS and Amazon's cloud is less than $1,000 a month. So that's a profound reduction in price, and it's still going down because of the competition from Google and Microsoft. Okay, let's give some examples. So today, the largest video service is a software company called Netflix. In the US, there's also Comcast and Xfinity. Time Warner is actually converting or transforming all their companies under their holding company to use software services. The most dominant music companies are, well, Apple iTunes, Spotify, Pandora. The traditional record labels just provide these guys with content. You don't hear about them anymore. So the revenues from these digital channels totaled around 4.6 billion in 2010, growing 29% year over year. In the entertainment business, there are fast-growing entertainment companies. Namely, they are really the video game makers. Developing video games became a very sophisticated business, and they are the largest companies growing in the entertainment space. Pixar is one of the really prominent video production company, and it's all software based. People are old enough remember Kodak and Polaroid cameras. These guys don't exist anymore. Photography has completely changed due to software and SaaS. Companies like Shutterfly and Snapfish and Flickr, stepped in and totally eliminated the local players. The biggest digital marketing company is actually Google. The fastest growing telecom company is actually Skype and Zoom. I prepared these slides before the rise of Zoom and Blue Jeans and WebEx. LinkedIn is the fastest growing recruiting company. The recruiting market is around 400 billion. It's a $400 billion industry, and LinkedIn is the most prominent recruiting company right now. The car industry. So most cars, I think we now know during COVID. I'm sure you guys heard about that. There is a major shortage in computer chips. And guess what? Modern cars cannot survive without these chips. Much of the car is actually driven by software. And that's why actually there's a huge shortage in supply in cars, at least in the US. And even used cars are now in short supply because people are buying them more. And we are talking about autonomous vehicles, I would say in less than 3 years. There are autonomous vehicles on the roads of San Francisco. They took a license recently. You can order a car and it will either deliver something for you, or you can use it to go from one location to the other. This technology is far from proven right now. It has been proven for some time. It is actually proven to be safer. and decreases possibilities of course, the EUI, like, driving while intoxicated, some driver not paying attention, and so on. They are actually safer. We're just missing some legislation to cover liability issues and many of these things, but they are a reality. And I think they will be mainstream in few years. Other industries. So in retail, like Walmart, has a huge power logistics distribution capabilities. And it was able to get some of its competitors like Kmart out of business because of how well they are doing actually these logistics. It's fairly complicated to know exactly what to display on the shelves, what to show, what to not show, who is going to buy what. All of this is based on software. FedEx, now UPS, has a huge software network that drives their trucks and planes and the distribution hubs. Airlines, I mean, that has always been a complicated business. Pricing is very, very tricky. And thanks to SaaS right now, this is starting to be manageable, still crazy. But without it, prediction models for big tickets software is really vital. Other industries like oil and gas, agriculture, of course, financial services. Every financial transaction that's done is done in software right now. There's no, that's just the case. PayPal, for example, which is a payment system, I think very much like Fowry here, if I'm not mistaken, generated more than $1 billion in one quarter. Okay, so what is next? This gentleman, Joseph Schumpeter, is an economist, German economist. He coined the term creative destruction. He would have been proud. It's exactly what we're living through. We're destroying. There's a sense of destruction happening through traditional businesses, and they're gradually being replaced by software. Not just software that we're going to see in a few slides, and the old traditional sort of leaders are going out of business, and they're replaced by software developers. So what's next? I think healthcare is definitely on its way of a major overhaul, mainly because how expensive it is and how much software can actually help with the cost. Doctors are in high demand. There's not enough of them. So having automated systems that would attempt to do basic stuff would help them become much more efficient and hopefully lower the costs. Education, of course, online education has been with us for the past year or two. It hasn't been great, but I think it's here to stay. Colleges like yourself, I'm sure you guys provide, or maybe you're thinking about it, providing online education services to people, especially in these times of crisis. But I think it's here to stay. It's not becoming justifiable anymore to charge very high fees to go to grade school like yours or an Ivy League school while to consume the curriculum from home, and also get great teachers and tutors and professors to interact with in a much more efficient way. So in some industries, software is an opportunity for Silicon Valley style startups to invade existing industries. My startup actually, Wisea, was an attempt to do that for meetings. We helped transform meetings. We created a meetings platform that people can interact with each other, create action items, schedule, become much more efficient, and not really need to meet face-to-face and not need to meet as much as they used to. Okay, so I think this really tells you how much SaaS is influencing lots of traditional business. Okay, this has been happening for some time. So what's new? The rise of machines learning is what's new. Machine learning algorithms right now, they can automatically learn from data, as you guys probably know, and traditional programming cannot do that. And we'll explore the difference between traditional programming and machine learning here. But as you probably know, many of the tasks that we consume day to day involves actually machine learning. Web search is one of them. Spam detection in your email, recommender systems that you can see in Netflix or Amazon, the ads that are shown to you, whether in Facebook or Google, that uses as ad placement, which is AI enabled. The credit scoring, if you apply for a loan or something like that. Some credit scoring is done by the bank. It involves machine learning, detecting fraud, from online banking or any other online services, trading stock, drug design. This vaccine, especially the mRNA, would not have been possible in this short period of time without fairly advanced software that uses machine learning. Okay, so how do we learn? This is sort of a fairly simple diagram of how we actually learn. Like a special type of learning called reinforcement learning. There is an agent and there's an environment that we interact with, and the agent always gives us feedback, either explicit feedback on this is a chair and this is a cat, or no, this is not right, or gives us a reward if we made the right guess, and gives us a penalty otherwise, depending on the type of learning we're talking about. So our parents keep telling us what a chair is, and we point to a table and say it's a chair. They tell us, no, it's wrong. And hopefully they don't punish us for that. If they just tell us that it's wrong, that's called, or somehow penalize us, it's called reinforcement learning. If they explicitly tell us, no, that is a chair and that is a cat, that's more of traditional learning. Nobody noticed that nobody sits us down and tries to explain to us what is chairness. That, oh, a chair is this device with 4 legs and a base and a back. Nobody does that. We infer that on our own by seeing enough chairs. And that's a fairly important concept. So there are many types of learning. There is classification. That's the most common type of learning. There is regression. It's very similar to classification, except an analog value is being estimated. There's ranking, the ranking of search results in Google. That's a form of machine learning. There's recommendation, which we all see in Netflix and Amazon, for example. The inputs can be of 2 types. They can be discrete, meaning that they are categories like someone's gender, someone's ethnicity, or continuous. This could be their age, their weight, anything of that sort. And in the case of classification, which is the most prominent type of machine learning, the output is a discrete class ID. I'm trying to just classify a particular input to being one of the classes. Let's say a binary classifier, meaning is 0 or 1. So the output is a class ID. Okay. Let's take the spam detector, for example. If input can be a Boolean vector describing the words in the email. If every word is assigned an ID, so I have a huge vector with the words turned on, with the bits turned on for the relevant words and turned off for the words that are not present in the email. It's just a huge binary vector, and the output is either 0 or 1. Is this spam or not? That's just an example. There are various, as the diagram shows. Sorry, there are, as the diagram shows, there are other types of major categories in learning. So we talked about reinforcement learning. The classification is of the supervised learning type, meaning that I have examples, I have data examples that are properly classified, and I want to build a model that would explain this data or model this data such that I can continue to do predictions that match the data that I've seen before. There's another type, very important type of learning called unsupervised learning, where I don't have the appropriate class of the example. And it's very interesting because going back to the chair example again, we don't see all the chairs in the world. And we only get told what's a chair by being given 3 examples. We don't need 1,000 examples of a chair to explain. So there's some kind of unsupervised learning that's happening. You know, when I see several chairs, after seeing 3 or 4 and being taught what they are, I don't need to be told what's a chair afterwards. And I'm building the concept of a chairness in my mind. And I don't need a million chair example to learn. So there's some kind of unsupervised learning that's happening in the human brain. Okay, so what are the components of a machine learning system? There are really 3 important components. There is the representation, there's the evaluation, and there's the optimization process. So representation it's sort of the hypothesis space of the learner. Is this a certain type of function? Is this a bunch of decision, or answers to question, for example, in decision tree-like fashion? Is it what kind of features that are being used? And the inputs, what are the types of inputs? Are these sensory signals, for example, like in vision? Are they or audio, voice, that is, or language? Or are they more highly engineered features, which is, for example, in ads or something like that? So representation is very, very important, extremely important. And in fact, we are living in an era where we made significant advances in representation, such that we just feed for a big set of problems, not all of them, but where we feed in the raw signals, and the model itself learns its own representation. That's why it's called representation learning, and it has been working very well. In any case, so the next component is evaluation. Is like, how do I know what a good classifier is or what a good model is from a bad one? I have to have some criteria or function or objective function that tells me what's a good classifier, what's not a good classifier. And it's fairly easy. So I have to express my needs in terms of some evaluation function. And then one of the most, I think I would say it's the most important one, is an optimization technique. How do I start from an arbitrary model or a model whose parameters are totally arbitrary and random, and actually apply optimizations driven by the data that I have, my objective function, and incrementally reach a model that is highly accurate and satisfies my evaluation function, optimize it to a great extent. So optimization is key because it needs to be done well. It needs good guarantees that's going to work, and it needs to deal with lots of issues in the data, and it needs to do that in an efficient way and not take forever or take a very long period of time. The quicker it does that, the better, and it needs to be fast to do that. So many of the innovations that people made in machine learning space has been the optimization component. It's very important also to know that what we hope from models is that they would generalize and not memorize. I think we Egyptians, we always have been told, which is exactly the same thing. We need our models to generalize and understand, not memorize, because it's actually, there's this sad situation where for any serious problem, there is no data set that you can memorize that would help you predict in a reasonable way, because the combinatorics for any serious problem is just so high. Take the example of the spam if we were to memorize all the possible spam words in the training set, it's not going to be enough. So if we have 100K vocabulary and we have 100 billion, examples of training set, we memorize them. Well, okay, so think for an email, I don't know, what would have 100 words or something like that. So you have 100 to the power 100K. That's the number of examples that you need to memorize for you to have solved the problem. And this is, completely unreasonable, completely, unachievable. So, which means you cannot get away for any real problem, of course. On toy problems, perhaps you can. So you have no hope but to generalize. And that's a very important thing in machine learning practice. So just know from the onset, you can never have enough data to train. The more data, the better, and you'll always get better accuracy when you have more data. There's also this theory called no free lunch, which is the British philosopher David Hume figured it out like 200 years ago in a sort of related field, is that there's no learner that can beat random guessing over all possible functions to be learned, which is really a sad reality. Okay, so this means really you cannot learn. However, here's the trick. It turns out that most functions in the real world they have certain properties. Like if that didn't exist in nature, we would have been in real trouble. So most of the, real functions in the real world, they turn out to be smooth. They turn out to be of limited complexity. And they, in essence, follow Occam's razor, which is if there is a simple explanation, in the absence of any evidence, if there is a simple explanation to something, then it's probably true. For example, like you're seeing me right now in the picture, so there's a good chance that one explanation is that I'm a real human being, a male, who's residing somewhere, and I'm on Zoom. Or there's another explanation that I'm actually a bot, and this is a humanoid, and someone designed a humanoid, and that's another explanation. There's another explanation that I'm an alien from space or something like that, and someone imitated. So these are all much more complicated explanations, and there's no evidence to anything that would favor one against the other. However, most probably by far the simplest explanation is the one that is true. That's why conspiracy theories are probably wrong, because they involve very unlikely events. I mean, sometimes they are, but simple explanations are the most rational thing that people should use. Anyway, so machine learning really capitalizes on these properties. And that's why it tries to find functions that are smooth, of limited complexity. And that's why things work. Otherwise, it would not have been possible. Okay. So, so what's really the difference between, what does machine learning actually add? So machine learning takes us from the deduction space to the induction space. So what's the difference? Deduction is mainly like philosophy. You have a set of axioms, and you have logic, rules of logic, ands, ors, and a set of rules of logic that people came up with over time. They understood, and then you can build on the axioms. Deduction is different. It's a power used by ML. So there's certain hypotheses that it can reach, and it's not directly deducted from the axioms, but it is most probably true to a great extent. And the more accurate the model, it's highly unlikely that it is actually true. So, and as a result, you actually reach a much richer set of facts or hypotheses. So you kind of trade off, confidence in the facts with the richness of the facts that you can actually produce. So that's the fundamental difference. So بالعربي deduction استنباط induction هتبقى استقراء. These are the closest translations I could find. So machine learning is really not magic. You cannot get something out of nothing. All it does is it actually gets you more from less. I think a good analogy is that learning is like farming. You combine knowledge with data to grow programs. So you don't write the programs explicitly. If you write a program explicitly in any language, it will follow this algorithm or whatever strictly. That's not the case of machine learning. There's a program that you don't directly write, but you learn from data. And this program, as said, explains the data that you have if you're any successful in building the model. And it should be fairly good at predicting similar data that you can see afterwards. That's the fundamental difference. Okay. So people talk about big data. So turns out 90% of all the information in the world have been created in the past 2 years. Imagine. And the rate of data creation is doubling every 1.5 years, thanks to the internet. In 2015, every minute, people did 4.2 million likes on Facebook, uploaded 300 hours of video to YouTube, and sent 350,000 tweets. These numbers today are dwarf these numbers even higher. Data, fortunately, is exactly what machines need in order to learn. So we have plenty of it. Okay, so that's all good. So we talked about SAS, talked about machine learning. So something interesting happened in 2016, March 2016. So remember that date. Something actually, some of you may have noticed it, but maybe many did not. It's essentially, I would say, it's changing the world forever. And it had impact on economy, on technology, on labor market, as we were talking about. So what happened? Let's talk about deep learning a little bit. So, as an introduction to telling you what happened. So deep learning is a new class of machine learning. It is essentially an attempt, neural networks are an attempt to mimic what we think is our very naive explanation of how the human brains work. Human brains are interesting. They're not good at traditional programming, the von Neumann type of programming, conventional. So if I ask a person to multiply 2 6-digit numbers, most people would not be able to do that quickly, but a computer can do that very, very fast, very quick. It has an algorithm sequence of instructions that it executes. However, a computer struggles to recognize a face, and humans can do that in a very simple way. So turns out the brain is composed of very simple processing units called neurons, and they are very simple, CPUs, if you will, that only do a set of multiplications and additions and emit an output. There are billions of neurons in the brain. They're interconnected. There are trillions of connections between these neurons in the brain. And almost everything we know are coded into the weights that exist between these neurons. And over time, all we do is update these weights, and different portions of the brain specialize in certain cognitive tasks. Okay, so people attempted to build neural networks with certain properties. A deep neural network is composed of a fairly large number of these layers of neurons. Of course, these are simulated neurons. And we came up with algorithms that would update the weights to learn certain tasks. Okay, all right. So a deep learning technique was able to, there is this game called Go. And Go is a relatively difficult game. It's actually harder than chess. I don't know what my friend Muhammad Zahan would think. He's a chess master. So it's apparently it's a very hard game. So new class of machine learning, deep learning, it actually defeated the 3-time European Go champion. His name is Fan Hu. 5 times in a row without a defeat. It's a huge surprise. Okay, at that point of time, the world champion is a Korean person called Lee Sedol, and there was a game that was scheduled between an algorithm called AlphaGo from a company called DeepMind that is owned by Google to play against Mr. Lee. And the China top Go player predicted that Lee would not lose a single game. Lee himself, humble person, he expected to lose 1 at most. All right. He lost all but 1 of their 5 games. Okay, this was a huge surprise. So this AI named AlphaGo, as I said, it's invented by DeepMind, became a better Go player than any human, and has been ranked the divine, which is sort of the highest rank in a 9-level ranking system. So Go has fallen to machine, just as the Jeopardy game, for example, happened to Watson, and of course we know about Deep Blue in chess. But this was different than chess. Go has been challenging AI and science for a long time. Okay, so people think we went through a major quantum leap, or let's say a hockey stick change. So if you look at this graph, this is sort of human performance and machine performance, as we're progressing over time. So as you can see, the machine performance, which is the lower graph, we saw a hockey stick change recently, and it seems we have exceeded human performance. Humans also have been improving. Human civilization in general develops good techniques and advances its sophistication, intellect. So there has been also human improvement, but it looks like we have crossed the line, and there are at least a certain subset of tests that machine is becoming better than humans at. And we'll talk about them. And it's not just about any tasks, and that would explain what the issue is. So the real issue is that we were not prepared, and we are not prepared, or at least entirely, for such a change. And it poses a lot of challenges. Okay, there has been traditional people who study the employment market. There are 4 types of jobs along the axes of routine, non-routine, and cognitive versus manual, or intellectual, if you want to call it, versus manual. And as you can see, the routine ones, this is actually the number of these type of jobs, over time. So as you can see, the routine jobs, they have been largely automated, and they haven't enjoyed, in fact, they dipped quite a bit, and it's quite stable. We haven't seen an increase in years, decades. Okay, but of course, the non-routine cognitive and non-routine manual, we're seeing strong growth. The novel thing here is that AI is able right now to replace jobs in these 2 categories, in the non-routine jobs, and even the cognitive ones. That's the novelty, and that's the serious thing that we're facing. These jobs were typically fairly high pay too, so it's not it's not necessarily, as I said, blue collar or low paying jobs. So it is a game changer, and I don't want you to think that this is something that's going to come in the future. This is happening right now, and the computer technology has been eating jobs, and since the 1990s. Will it only impact industrialized countries? Not really. And I will show you how it can impact us in Egypt, even though we're an emerging market or developing nation, it will still impact us significantly. We are living, as I mentioned, it's another industrial revolution. Something like that happened before, at least once, if not twice, in the 1600s, 1700s. And there's a lot to learn from that period. Not sure if you guys have seen this video, but why don't I show it? Just can you guys see this video? I'm assuming yes. Anyways, so you can really tell how sophisticated the robotics, and this is from a few years back. I'm sure it's there are lots of problems that are involved in robotics, like mapping and manipulation, are solved or on the way to be solved, and we can really imagine how much these things are. These robots or their humanoid versions can actually replace jobs in factories and mining and all of that. I visited Tesla's factory a few years back, and I saw very few humans. Much of it is actually inhabited by robots for assembly and simpler and not so simple stuff. Another example is radiology. So in 2017, Stanford showed that they can diagnose pneumonia better than radiologists. And there are several other diseases that have recently also shown that that's the case. So radiologists, if you have any radiologist friends or family, give them a warning. They will be replaced, at least partially, fairly soon. There are many other advances in ML. For example, we're doing, a fantastic job in image recognition. We outperformed humans in the early 2010s. And for example, not only can we tell that there's a horse, we can tell what type of horse. Maybe you can even have a guess about the environment that they're living in and stuff like that. Google, describes itself as an AI first company. Given the priority and the advantages this actually gives it in the market. Global investments in private companies focused on AI increased from 589 million in 2012 to 5 billion in 2016. And I think this number is close to 10 billion right now. A quick note on the economic growth. So this graph shows the economic growth in the whole world, in the US and emerging markets, and so on. So in non-emerging markets, things have been fairly stable. This labor productivity growth metric, LPG, increased by 1.3% from 2015 to 2016 every year. That's less than half of the period before that, from 1995 to 2004. So there's kind of stagnation in LPG, in the labor productivity growth. And okay, so if we take a look at some examples of call centers in the US, if speech recognition can handle 60 to 70% of the calls, this would mean an annual productivity growth of over 1%. So I'll just give you a couple of examples and look at the productivity growth, something that hasn't happened in decades. So it's not something that people can ignore. It's here to stay and even be more pervasive. There's other productivity examples in data centers. If we know how to cool and when to not cool, there's huge reductions. Here's an example in Google. It's about $6 billion a year, and using machine learning, they help reduce that cost significantly. So AI is this class of general purpose technology, and it can be applied to many disciplines and many areas. Steam engines were also another general purpose technology in the first industrial revolution. So it spawns, complementary innovations and increased productivity directly and indirectly. So these are the kind of technologies that actually cause major breakthroughs and significant shifts in lifestyles and economic fortunes of people. So what does this mean for the labor market? It means that this exponential technological change, will impact the labor market significantly. From hamburgers to healthcare, machines can successfully perform these tasks, and will need less or may not need humans in many of these tasks. Okay, there are many hard questions to answer. Should income itself remain coupled to employment? It's a very important question. Is having a job the only way to obtain income? If machines are performing an increased percentage of our jobs and are not getting paid to do them, where does this money go? What do we do with this money? Is it possible that many of the jobs we're creating don't need to exist at all? Are we just creating them to pay people? Sorry, I'm a bit over time. I'll finish right away. So there is a proposal which is really interesting, and I'm a big fan of, called universal basic income. Essentially saying earning a decent minimal income that you live a decent life should not depend on employment. And it's being experimented in various parts of the world, in Europe and even some states in the US, and it's showing actually lots of success. Essentially earning an income, a basic income, is a human right. It has nothing to do with employment. Okay, this is my last slide and punchline. So this is a big challenge for us. And I mentioned, something like autonomous vehicles, education. Can you imagine the impact of us in here in Egypt, for example, if there's no demand on Egyptian drivers in the Gulf, for example, or on educators, it's going to impact us significantly. And I'm sure Egyptian companies, some of them are going to seek automation to reduce their costs and productivity. So it's a big challenge. And many people lack education and skills required to participate in this new economy. So it's a big challenge, but I'm a big believer that every problem has hidden in it an opportunity to create. And most of the real big contributions in the world were invented during wars and crises, including the mRNA vaccine that we're all benefiting from. So this is an opportunity for us to create a service economy. We have a huge population, and education is improving. We have truly brilliant people. I've interacted with many of them. This could be for us what software engineering was for India. And I'm very, very glad to be in a university that's taking this on and taking this specific sort of area of expertise as a goal. And I'm really positive and hopeful that you'll create enough in the labor market that would let us contribute. There's a huge demand for people like yourself who can be data scientists and AI scientists and engineers, and it's time to actually contribute to that sort of human civilization with our innovations in AI. And I'm full of hope that it will be your generation and the generation after that will make this major shift in our economy and lead us to this sort of new era. So thank you very much. I'm happy to take questions. Sorry for taking a little more time than scheduled.
Thank you, Dr. Ahmed, for the speech. It was a very nice lecture. Thank you. And we really appreciate your time. And we hope that you get better soon, inshallah. Actually, we have a couple of questions on the chat. I would like to share them with you if you have time. So the first question that we have is asking if you can shed some light on the issues of bias and fairness and how Facebook or Meta might be addressing them.
Yeah, that's a great question. So responsible AI and fairness in AI is a very important topic that many people are paying attention to. It's no longer acceptable to say that the data has biases, and so because we're building models using data, then somehow we inherit the biases in the data. There are major investments into evaluating AI models in a fair and more responsible way. So, for example, it's no longer acceptable to just rely on a mean accuracy or mean error rate, because most of the distributions we're dealing with, it is said actually that most of the human-generated phenomena follow a power law distribution, which accounts for a big part of it, but they're very, very long tail. And actually, the mean is not a very good descriptor for these types of distributions. So we need better metrics, and people are devising better metrics to measure performance on these power law distributions. And there's great work at Facebook and outside of Facebook on actually addressing that. The other thing is, unfortunately, the internet is full of data that has bias, and especially Arabic content, actually. And I think we're yet to, as sort of Arab-speaking people, create good content and to contribute to that. So short answer is, it's a problem that everyone is focused on, and including in conferences, you'll see lots of the results reported right now go beyond just the average. They go into the details, make sure that you're not suffering from the tyranny of the majority, as they say, accounts for all the distribution, including the data.
Okay, so we have a second question, please. Can we develop machine learning tool for real-time conference translation? Can it be possible to translate between two languages in real time between two persons speaking two different languages?
That's in the works. I'm thinking less than a year, you'll see that. So currently today, there is automatic online transcription, audio to text. That's like in WebEx. Actually, my company is the one who contributed that, and it's part of WebEx right now from Cisco. So there is automatic transcription right now. And we know machine translation is also fairly advanced. text-to-speech is also has been viable for some time. So we have all the pieces. However, these days, actually, speech-to-speech directly is in the works. There are very interesting papers that have emerged recently. I think to commercialize it, we're a year away. Essentially, taking an audio from a specific person, translating it, the audio, generating it in any arbitrary language in their own voice. So that will happen soon. Give it a year.
Thank you, Doctor. So we have a couple of more questions. You shared the list of overvalued versus undervalued companies based on P/E ratio. Where do you think AI-based companies will fall over the next few years? Overvalued or undervalued? Will they also use the same ratio multiple that you shared, 15 to 16x?
Okay, I think the story is interesting. Startups, in particular, the AI ones, they tend to be overvalued. You know, like it's fairly easy to go to a VC and with an AI idea and get funding, and the valuation is like crazy. So I think they are overvalued for startups. And once the company goes to IPO, it's undervalued because of the skepticism from investors, the one that I talked about. So it's a kind of a funny story. Undervalued on IPO and public companies, post-IPO and public companies, overvalued for startups. I think you can see it here in Egypt. I look at the startup scene, and any company that has an .ai in it, in the end, whether they are doing AI or not, tend to be valued at big amount of money that sometimes is not justified, in my opinion.
We have one more question, Dr. Amani. You can pose your question.
Thank you very much, Dr. Okay, do you think our students stand a chance capturing part of this AI global market? Do they have to travel, or can they create, AI-based startups in Egypt? Is there a window of chance to do that?
Yeah. So the answer to the first question is absolutely yes. Because of the simple math, so the gap between the supply and demand for, like, we woke up one day and everyone wants AI engineers and scientists, and there's just not enough. I'm talking worldwide. There's just not enough of them. So it's a sort of a seller's market, to the extent that people now just settle for a certificate in data science. Many companies don't require, they rely on experience. So I think that definitely yes. I don't think everyone needs to leave or anything. I think we can provide services while from here, whether to develop AI solutions for the local markets or to compete globally, because there's a high demand, and demand will not be specific about whether you're living in Egypt or you're living in Canada. So there is an opportunity there. Yeah.
Do you think that the current ecosystem needs some adjustment to be able to host such startups?
So I'm judging from what I see, and I'm definitely not an expert. I think yes. I think there needs to be more. Companies need to build more credibility about. Like I'm watching many of the discussions about the ecosystem, and some of the complaints I'm seeing is that there's just not enough credibility when companies report their performance, how much they're meeting their KPIs. And so these things ruin the whole ecosystem when there's not a trust between investors and companies. It's a very bad practice. So it's very important, that things become transparent and truthful and credible. Otherwise, the whole ecosystem is going to fall. So that's the primary thing. The other thing is, again, it would be a problem if the AI term became diluted, and that it would be added just to be publicly for PR purposes. So I think there has to be some truthfulness there, and I don't know how it's going to be enforced. But if the term got diluted, then no one is going to take you seriously. So that needs to be somehow taken care of. Other than that, I think I'm seeing lots of positive signs there. The ecosystem is really impressive, and and I'm seeing things that I really didn't expect to see.
Thank you very much.
Dr. Ahmed Sharaf is raising hand.
Yeah, thank you very much indeed.
Yes.
I have a comment, and I would like to know your opinion about it. That despite all of these advancements, we still have problems with something which is much easier than robotics, like spam filtering. Spam filtering right now, you must go to the spam or to your junk mail and check that they are really junk or spam mails, etc., etc. So, what can you say about this? Another point is concerning the implications and the negative side of those advancements in AI, in robotics in particular. I watched the video you kindly show us, and then what can happen if the robot, after being pushed by the man, he just turned out and then start killing these gentlemen? Thank you.
Okay, yeah, that's the easy part. So spam has improved quite a bit. I'm sure you've used it like 10 years ago, and it's a far better technology. The problem with spam and adversarial problems like this is that it's an arms race, meaning that you develop technology and then there's someone on the other side who learn what you're doing or reverse engineer it and then come up with a technique, which is, but I would say it has improved quite a bit. It's not perfect, and I don't think it will ever be perfect, but it's way better. I personally don't lose anything to spam except very like one in I don't know, one every and there is always novel spam, but it's really novel. Someone or some entity that I have not encountered before. So, and I just, all I have to do is add it once to spam and it's just done. So my experience is not perfect, but it's relatively good. On the adverse, this sort of doomsday scenario for AI, I think, as a practitioner and scientist in the field I think these are sci-fi type of predictions. The sad thing is that, and I'm going to say something controversial. So there are lots of really smart people like Elon Musk, like even Bill Gates, who know nothing about AI. Not because they are clearly, luminaries and very smart people, but AI as a paradigm is extremely different from anything we have seen before. As I said, it doesn't follow the traditional von Neumann computing paradigm. So unless you are a specialist or literate, at least in the field, what their predictions about AI is nonsense, in my opinion. It doesn't make any sense. And I'm putting aside that some of them do it for propaganda purposes. So we are very far from, we haven't even scratched the surface. We're still very primitive. So the idea that somehow these machines are going to turn against us, I think is just a bunch of sci-fi. And it's really sad because this can actually ruin the field and maybe stop investments and stop grants in universities. These types of sci-fi predictions and the other ones too, the rosy ones that, we're now can build brains, and these exaggerations from the media in particular hurt because they give people the sense that we've solved problems that we have not. And when you solve them, you don't get any credit, and scare people by unrealistic expectations about doomsday scenario. So I'm very, I don't think this can happen with the current technology. Maybe in 40, 50 years, we'll have something like that. I would worry about humans and the evil and damage they cause in the world than worry about robots causing damage.
So actually, the topic is very interesting. We are getting lots of questions, and I would like Dr. Ahmed to finish our session with the last question from Dr. Marwa Hafnawi.
Okay, first of all, thank you so much for the wonderful lecture for today. I just have one question that may lead to another one. So probably you have heard from Steve Jobs when he was launching his iPhone And he used a very hard sentence, actually saying, a quote from Alan Kay, people who are really serious about software should make their own hardware. What do you think? Shouldn't software and hardware be hand in hand together? Thank you.
That's a good question. Well, they don't have to be the same people, but definitely whoever is going to design hardware for AI has to take its intricacies into consideration. And whether that's for training purposes or for inference, for runtime. For example, sadly, machine learning training is not embarrassingly parallel. I think Mohammed Zahran can give us a whole lecture about that. Which means parallelizing it is not trivial, and it turns out actually the techniques that we use, they make us faster, but they actually degrade the performance of training and need more iterations. So it's very tricky. So knowledge of the intricacies of the current state of the optimization algorithms for training is needed when you're designing hardware for that. I would agree. They don't have to be the same people. However, there's a very interesting twist. One of the people who had major contributions to AI hardware and training are systems people at Google, Jeff Dean, others. And they are not ML people, but they are really amazing systems people who understood enough about AI to be dangerous and cause lots of impact. Now, if your question is about building dedicated AI hardware, I don't think this worked. I've been doing this for quite some time, and I've heard about specialized hardware and ASICs and the like. And by the time these guys finish the design, manufacture, and mass production, the generic hardware beats whatever they built. So I think hardware advances need to be along the lines of the generic hardware, but equipping it, like the GPU is a great example. GPU was not invented for AI. It was invented for games and graphics and video and stuff like that. But we found great use for it in scientific computing. So I think innovations along this side, knowing what the AI intricacies are can be very effective. Yeah.
Thank you so much. This answers my question.
So by this action, I think we need to end the talk. Thank you very much, Dr. Ahmed. And on behalf of all the EUI family and students and faculty, I would like to thank you for this precious talk. And we are ready to meet you, inshallah, in person next time. And we wish you a quick recovery. Thank you very much.
Thank you. I would love to. I promise if you were to still invite me, I would, inshallah, next time I will definitely visit with you guys. Thank you.
Dr. Ahmed, that you can visit us before traveling once you are fit. So let's see what you talk about. Thank you very much. Thank you.
Thank you.